So from here we will open a new library and let the library be RADD and attach to the existing library. Okay. And that existing library may be GPDK 180. Okay. Now I will create a new cell view. Cell view name I am putting MUX 21. MUX 21. Okay. Black color window will open. Yes, this is the MUX 2x1 MUX. One PMOS, one NMOS connected face to face. It is called transmission gate. PMOS on the bottom, NMOS on the top. The connection can also be done like this. PMOS can be connected on the top, NMOS on the bottom. Either way it can be connected. This is a symbol of transmission gate. Now two such transmission gates we have to connect one below the other. Then we have to connect their drains together, output will come. Sources together, input we have to provide. This same I will design in the cadence. So this is the cadence window and I have pressed I instance, and then from GPDK 180 I am taking one PMOS transistor, close, hide. So one PMOS, here again one PMOS, escape, again I from keyboard, browse, and NMOS transistor I am taking 2 in number. I will keep below the PMOS. Now select the PMOS transistor and rotate right. Drain will come on the right side. Select the PMOS transistor, rotate right. Now select the NMOS transistor, rotate left. Also flip horizontal. NMOS transistor, flip horizontal. Then select it and keep exactly below the PMOS transistor. Select the NMOS transistor and then rotate left and flip horizontal. So now select it, put properly below the PMOS transistor. For PMOS we have done only rotate right, drain will come on the right side. For NMOS we have done rotate left and flip horizontal. So its drain is on the right side, source is on the left side. So drains are together to be connected, and sources also together it should be connected. Similarly here drain should be connected together, source should be connected together. I will take wiring, connect the drain terminals together, connect the source terminals together. Now join the drains here. Put a hanging point. This is the floating wire for output. And here is our first input. And here is our second input. Now the other things, if we see, we completed this portion. This transmission gate, the drains are connected together. Z is the output, that also we completed. And then this A input and B input we completed. Now here we have to join the PMOS, NMOS, and S bar should be connected here, and bottom and top S should be connected. So for this I have to join. Here I will leave a floating wire. This is S terminal. I am connecting it to the top. This both are S input. Now I am connecting these two, and here I have to give S bar. here I have to give S bar. So for S and S bar, I want one inverter. So what I will do, again I will take one PMOS and one NMOS transistors, one PMOS for creating inverter. This is PMOS transistor, and I have to take one NMOS transistor, escape button. If you press F, it will fit to the screen. I am connecting the gate terminals together, and here we have to join them. Output is S bar, so I am taking it upwards. S bar. Input is S. Input is S. I have to connect it appropriately. Input is S here. Input is yes. One dot over the other should not come. It will give error if you create one dot over the other. This is yes input. This is yes input. Now what I will do, take a wire, wherever PMOS is there, give a small floating wire, blue color, give a small floating wire, wherever PMOS is there, give a small floating wire for all the PMOS. We know PMOS should be connected to VDD, so I am connecting here. I am taking wire and connecting in the inverter particularly, in the inverter. So in the inverter, all the PMOS transistors, I have given some small extra wire. Click on this label icon and I will take VDD, touch this PMOS wire, labeling is given. Again take label VDD, and this wire if you touch, it will be labeled as VDD. Again label VDD, and you put on this wire, if you touch, it is labeled as VDD. Now I will take wire for all the NMOS transistors. I will give a small blue color wire for all NMOS transistors. For all NMOS transistors, I will give a blue color wire. Here I know NMOS should be connected to VSS, so I am connecting it to VSS, and one small extra wire we can give it downward. This should be labeled as VSS. Now click on this label, give the name VSS and touch this wire. VSS will come, escape button. Again label VSS, touch this wire, it is labeled as VSS, and one more time label, give the name VSS and label this wire as VSS. Now I have the circuit done. I will give the pins. Press P from keyboard. I am taking VA as the first input. In the drop down, input should be there, so keep it here. This is VA input, escape button. P from keyboard, VB is the second input. Drop down input you have to check, and then here is the second input. Again P from keyboard, and selection line, SCL selection line, hide the pin, input pin, selection line is here. And now again I am giving VDD input pin only. I will keep this pin somewhere on the right corner. Again P from keyboard, VSS input pin. I will keep this also on the right side. All these 5 are input pins: VA, VB, selection line, VDD, VSS. Again P from keyboard. Now I will take V out, and in the drop down, output pin. This is the only output pin, and I have to connect it at the output side. So 5 inputs and 5 inputs and 1 output. So this is my overall circuit. If you do check syntax and see in the CIW window schematic is saved with no errors. So schematic completed. I am going to create symbol, create cell view from cell view. So symbol of MUX21. I am naming, giving some name, symbol of MUX21. From the schematic MUX21, I am going to create symbol of MUX21. Okay. So all my pins will come on the left side. All these 5 pins, I don't want that. So VDD and VSS I want on the top and bottom. Other pins may be on the input side. So I am deleting this cut end, paste here. VDD will be the top pin and VSS should be on the bottom. VSS should be on the bottom. Other output will be on the output side. Selection VA VB will be on the input side. Now this is the symbol created. Now click on this into mark. Remove the red color, green color, port name, instance name. All this you can delete. Now MUX symbol we have to draw. Give escape button from keyboard and take this wire. We know the MUX symbol at the starting point, something like this. Then at the ending point you can draw something like this and take it. This is the MUX diagram. If still these gaps are allowed, but still if we are at the ending, we have to give double click. So these gaps and overlap are allowed in the symbol. If we want, we can give it connection. Otherwise we can leave. These gaps are allowed. These gaps are allowed in the symbol. Overlap is allowed, gaps are allowed. So this is the MUX symbol. I have completed. Overlap means this extra wire. All these things are allowed just for convenience or for good impression. I have completed. And now check and save and see that no errors warnings are there. In the symbol creation also no errors and symbol is also created. So we can close both of this schematic and symbol. In the CIW window I am going to create a new cell view. Now the cell view name MUX_TB, MUX21_TB. A new black color window will be opened. So here press I from keyboard, and in our library we have saved it. I didn't check that actually. My library name I have put RADD. I didn't save inside it. That's the problem. Somewhere I have saved. Cell view somewhere I have saved. 1 minute. MUX everything whatever I created I have saved somewhere. I should create inside my library. So it is saved in CMOS. Okay. My library name I am changing. CMOS I have created this one. So I will go with the MUX21_TB, which I already created. In the CMOS library, RADD I have created, but while cell view I didn't concentrate. I kindly excuse. So here instance I from keyboard. In the browse button, CMOS one library is there. CMOS library. My schematic is saved. This is the library, and here I have created the MUX21. If you select this symbol, you can see. Actually, we have to check while creating cell view. We have to check inside our library. We have to create it. So here, no changes. Only one symbol is enough. And now I am going with I from keyboard. From the analog library, I am going to take VDC. Alphabetic wise it will be there. So VDC, close, and DC voltage 1.8, and I will give it, don't come inside the yellow color region of this MUX. So keep it little far away. Escape button. If you come near the symbol, yellow color dotted line is there. Don't bring any components inside this dotted line. So I from keyboard, then V pulse, close, hide. This is the first input. I have to give some names also, kindly excuse. Escape button. I am deleting this. I from keyboard, I have taken V pulse. So the first voltage 0, second voltage 1.8, second voltage 1.8, time period 80 nano. Nano compulsory we have to give, otherwise waveform will come for only for one iteration. 40 nano is pulse width. On off time 40, 40. Total time period 80. So I am taking 80 time period for the first input pulse. I from keyboard, another input I am taking, and 1.8, 1.8. Now I will give 40 nano and 20 nano, half of the previous. Time period is half of the previous. This is my second input. And again I from keyboard, amplitude same 1.8 I am giving, and the time period half of the previous, 20 nano, 10 nano. Okay, 80, 40, 20, three inputs. Three inputs I have taken. I from keyboard, and from the analog library we have to select ground alphabetic wise. G will be there. Ground G will be there. Hide. We want for all these three inputs ground, and for this VDC also, for this VSS also one ground. Escape button. Take wire, connect all this to the ground. Connect all this to the ground. Connect the VDC. Escape button, because it is not properly from the starting point. Connect it to the VDD. Now first input I am connecting to selection line. Next input I am connecting to VA. Next input I am connecting to VB. And one wire I will take from the output side. Escape button. P from keyboard, and V out is the name of the output pin. I am giving one output pin here. So with this my circuit completed. Check and syntax, check and save. So no errors. My final test bench is created. For simulation, go to launch ADL, maximize. We have to wait until this window is maximized, because in the setup model libraries one option should come. Only then we can just execute it. So this is maximized, and now in the setup it is not yet opening. We have to wait. So in the setup model libraries, only this 180 nanometer tick mark should be retained. Other things we have to remove. Okay. Then analysis, choose in the transient response 100 nanoseconds, and moderate. Okay, the settings will come on the right side. Now outputs to be plotted, select on design, go to the schematic, select the three input lines. Color change will be there for the wires. Output wire also select. Color changes we can observe. Then come back to the window. All these four tick marks should be there. Four waveforms will come, three input and one output. Click on this green color button, and here right bottom you can see 0. It should execute. We have to wait, nothing to be done. So once it comes 0 to 100, automatically waveform, output waveform will come. Three input and one output waveform. So it is overlapped. You click on the split all the strips. So waveforms are split. You can right click on the waveform and change the color, and then we can make it solid line also. Solid line, it will come thicker, and we can also change the color, and then or any type of pattern. So we can see first wire is output. Okay, and net to 2 is selection line. You can see in this options net to 2, 3, 4, and in the schematic net to 2, which is net to 2. So you can see here three wires are there. 3 wires are there. When we come to the waveform, in the schematic, first one is selection line. Schematic first one is selection line. We gave 80 as the time period. So in the waveform, 80 time period means this one. This is the selection line. When selection line is 1, second input VB will come at the output. VB means we have given, for VA we have given 40 as the time period. VB we have given 20 as the time period. So now from here you can see this is VB. So whenever it is 1, VB should come as the output up to here. Green color up to here, red is equal to yellow. Whenever it is 0, selection line is 0, VA should come as the output. VA is blue color. This blue color output and yellow color. Blue color is the VA. Yellow is the output. Output is same as blue color. Okay, output is same as VA. Then selection line is 0. Okay. So this is about the MUX in cadence. Thank you.